This is Algebra 2, Lesson 115. It's exponential equations, exponential functions, and compound interest. 3 concepts in one lesson.
Let's go.
All right, I want to start with compound interest. So go to page 467. It's practical. Well, they're all practical, but it's what you'll use the most. Compound interest. So typically today, if you put money in a savings account, you're earning very little interest, right? You're not earning much interest today. But your interest is probably compounded daily, but you don't get it until maybe the end of every month. Do you have savings accounts? You get a little interest at the end of every month? Yeah? All right, so how do they calculate this, right? Well, here is the formula. The amount over a period of time equals the principal amount. That's how much I have in my account. It's your initial deposit or it's your balance, right? Your balance in your savings account. It's your principal times 1 plus the rate raised to time. Now this is the equation if I just have
Wait, is it 1 plus
the rate
1 plus the rate times time?
raised to the time, raised to the power of the time. This is if I have annual compounding. All right, so let's suppose I deposit $1,000 into a savings account, and I'm earning 2.5% each year. 2.5% every year. How much will I have after 5 years? Well, I can use this formula. So it's the amount after 5 years equals my principal, the $1,000 times 1 plus the rate, but the rate is not in percent form, it's decimal.
So
What is it?
0.25.
Right, I move the decimal
0.0.
2 to the left to convert it to a decimal. 1 plus 0.025 raised to the time. 5 years. Do that in your calculator. How much money do I have after 5 years?
So it'd be 1. $3,051.
Can't be. That's way too high.
1063.67.
What? 1063 sounds better. I'm only earning 2.5%.
I got 1,131.4.
I put it in exactly like it is there. No idea.
31.4.
What did you get? What did you get, Elliot?
1,131.
1.41. That's what I got.
That's what I got.
1134.41. 1131.41. So how much interest have I earned? $131.41. Not bad, right? You're not earning this much now. You're earning 0.0025. You're earning 1/4% in your savings account.
Didn't it used to be something like 4 cents a day? Like,
Well, it's always been a percent, but it did used to be 4 and 5%. Yeah. All right. That's if I'm compounded annually. What if I say they're going to compound me monthly? All right. We're going to compound
1/8%.
monthly.
Because it's not going to be.
Monthly. I'm going to deposit $1,000. Okay, wait. Annually, we had what? 11, 31, 41. That was annual. Now we're going to compound monthly, and I'm still going to be at 2.5%. Okay, everybody look, you have to do something different.
45 months.
You have to do something different, okay? And it's 5 years. 5 years is the same, all right? So the amount over 5 years is the principal, 1 plus, I need a monthly rate here. So this is always going to be an annualized rate. So it's 0.025 divided by 12 months in a year to give me that monthly rate. And what I raise it to is the number of months, which is 5 times 12 months in a year. So monthly compounding is different. Anything other than annual compounding is different. All right, so what is that in your calculators?
1,133.
I want my pennies. How many pennies do I get?
0, 0.
All right, so it's 11,
Because if, I mean, you wouldn't.
34. Somebody confirm that, please.
No, it's 1133.
1133.
0, 0.
I got the same number that we got last time. Yeah, 1133.
That's not.
Well,
Please.
I'm getting a little more if they compound it monthly, huh?
Well, $2.
Hey, that is.
Okay, but if I have 100,000 in there, don't you think?
That is 2 ices
Right?
at Circle K. Just saying, brother.
Got it?
I
A
can
shorter
think of two
compounding
bowls of rice.
period. A shorter compounding period
That's a zebra cake.
is better. Okay, now what if we did it daily? What if we compounded daily?
We'd have to multiply it by 365.
Yeah.
Actually, you'd have to throw in a leap year, so. There's an extra day in there.
Wait, so why do you have the 12
2
there?
leap years.
What? Because there's 12 months in a year.
Year, and then like you could do it in 2024, you go leap year, and then another leap year in 2025. So
You have to make that rate a monthly rate. Yes.
What if you wanted to do it over for like 17 days or something random?
They,
It just
yeah.
it can't be like that.
You'd have to figure out how many 17-day periods there are in a year, right? And then that would be 5 years times 365 days. Okay, but
1133.14 would make 14 cents.
there we go.
How about that?
All right. What if it's continuous?
What? You mean like forever?
No, like repeating?
Like every second. Every second.
I bet you're getting 2.5 on
It's
every
compounding. Okay, listen. When you hear the word continuous, we're going to use a different formula. The amount over time is the principal times E to the rate times the time. I call it PERT. When it's continuous, we're going to use PERT.
That's a type of shampoo.
I know. So we're going to use E. Remember, we just learned about E. That's the natural log, right? We're going to use the value E when it's continuous. So let's do this same problem. See how much more we're going to get if we have continuous reinvesting of that money.
So how do we do the time? Do we put
Okay.
in 5?
It's 5 years. So you're going to do the amount over 5 years is the principal, $1,000 times E raised to the rate 0.025 times time, which is 5 years. And what do you get when we have continuous compounding?
Oh, I did something wrong.
Come on, we need more than one person doing this.
I got math error. I got syntax error.
I got 1,133.15.
I got 1,133.14.
Same.
Well, I just rounded up.
I got 1,133.14.
0.15. Yeah, this is what I get.
Oh, that's fine.
All right,
Good
so
job,
we
Jen.
get a little bit more. This is the best compounding, continuous. So when you hear the word continuous, you're thinking PERT.
Pert.
Got it?
We just use E every time.
When you hear
Pert.
continuous.
Pert.
Got it?
Got it.
Okay, this also can be a formula. This is with money. But we also use the same type of concept. This is exponential, right? It's some base raised to some power equals a value, right? This is exponents, the inverses of logarithms, yes?
What's the monthly interest on ballot right now?
Like 1/2 of 1%. Okay?
Paul, you said
So we can use this same concept with bacteria
what?
or the reproduction of flies or the reproduction of fleas. Like how do fleas
Explain.
exponentially, right? Before you know it, they're all, you have rabbits. Rabbits proliferate exponentially,
Never heard that word.
right? Pro-life, they produce life, proliferate exponentially.
Those are big words. Those are big words that my small brain can't understand.
All right. And the formula, when we have exponential growth, is almost like continuous. Continuous was the amount over time is PE to the RT. Exponential growth is not with money. It's the amount over time equals the original amount, because it's not money. We only use P when we relate to principal, times E to the KT. K being your constant. It's really your rate of growth, right? It really is your rate of growth. It's a constant. All right, original amount, E, we know what E is, to the K, and T is
Time.
time. That's right. So, we can either have exponential growth or we can have exponential decay. This one works for both. It can either be growth or decay. Growth would look like this. Decay would look like this. All right, so things that decay over time is radiation. Radiation decays over time. So when Chernobyl had its explosion, they would have used this formula to decide when it was safe for people to go back into the area. They would have done air testing and saw how,
How long does it take?
I don't even know if it's clean now.
Like hundreds of years or something.
It's a long time. Yeah, long time. All right, but things decay, right? Trees decay, bones decay. Yes, lots decays.
Nobody realized.
I'm decaying. All right. All right, so we're going to use exponential growth. Look at 115.2. Everybody look at 115.2. I actually believe I have a video for this lesson. I'll send it to you because there's no way I'm going to be able to cover everything. But hang with me. In the beginning, there were 400 bacteria in the dish. That's the original amount. Got it?
Mhm.
The original amount is 400. The number of bacteria increased exponentially. When I hear those words,
E.
I'm using that formula. That's right, I'm using E. 3 days later, what's 3 days?
Time.
My time. That's right. So I know my time is going to be 3 days. 3 days later, there were 2,000 bacteria in the dish.
Constant.
No. 3
Amount.
days later, that's the amount after 3 days. I have 2,000 bacteria in the dish. I don't know what the constant is, do I? But can I solve for the constant?
Yes.
Yes, I can.
Divide by 400.
Correct. First divide both sides by 400.
So 5.
5 equals E to the 3K.
Take the cube root.
Wait. Can I use logarithms? I can.
It's all
When you're
coming
solving
together.
for the exponent,
Take the ln.
I can use logarithms. All right, so I can take the ln, my base is E. What goes here?
5.
5 equals what?
3k.
3K.
So divide by 3.
All right, so do the ln of 5 in your calculator,
1.6 divided by 3.
and then divide it by 3 to get the value of your constant.
0.536.
Anybody else get 0.536?
0.53.
You did something wrong.
Okay, here's what this is not. This is not the ln of 5/3.
Okay.
It's the ln of 5 divided by 3. Got it? All right, so now once we have K, let's finish reading. Because it wants to know how many bacteria will there be in 8 days.
So change time to 8.
After 8 days, I still start out
It's 400.
with 400, it's E, but now I have K, 0.536, and now I'm looking at 8 days. Should I have a whole bunch more? Say yes, because we're growing exponentially.
29,000.
I have how many?
29,128.27 fleas. Bacteria.
Yes. All right, so with these equations, you had to go in and solve for the value of K, right?